So Paul Irish is in the house. I'm so excited to have him here at Velocity. And Chrome has its own dev tools, and Paul is going to give us a little tour through those. So give it up for Paul Irish.
Cool. Woo. So we're going to go, and I'm going to show you a few features inside the Chrome Developer Tools that should meet your fancy. So firstly, demo's going great. Live demoing. Oh, yeah. Thanks. Yeah? Rock and roll. Okay. First, I want to show you the Task Manager. Normally it looks like this. I'm going to bring it up right here live for you. All right, here we go. So Task Manager gives you a nice view of your pages, your extensions, how much memory they're using in the CPU, the network throughput, even the frames per second now. But if you right-click, there's a lot more stuff that's available. You can kind of see the amount of stuff that's in the script cache, the CSS cache, the image cache, the JavaScript memory that's being used by the pages, and even probably the most important metric that you're going to want to watch, the number of goats teleported by each page. It's quite a lot of goats, it turns out. All right, so this is kind of like the 30,000-foot view, and we're going to go down a little bit closer, down to the bare metal. Okay, so there's a lot of new JavaScript APIs for monitoring. First, of course, is the performance timing, right? And I think we're all familiar with this here. This gives us a nice view, an object full of all the network timings that reflect the page loading performance. We've had this in since Chrome 6, and now, of course, it's unprefixed. But, well, that's all well and good. Now, in addition to performance timing, there's another one that we have available, which is called performance memory. So inside performance memory, we have a nice snapshot view of the memory usage of the page. And so this represents just this page, what the memory use is. I will point out that this is available if you execute Chrome with a command line flag, an enable memory info, and that will populate that object with information. The next I want to show is window on air. So window on air, support was landed for this in WebKit a few months back, which completes the cross-browser support. So now in a cross-browser functionality, in a cross-browser way, we can capture any errors that happen, any JavaScript errors, any exceptions that occur, capture them at the global level, and be able to work with that. Common use cases, you'll just take that and you'll report that back to the server because you want to know if your users are hitting landmines in your application code, and then aggregate that for a dashboard view. The next, I'm sure you're familiar with console.log. There's a lot more stuff on the console that you can access. So console.profile is an interesting one. Standard CPU profiling. We go in here, we do a little bit of action, we come back, and we have a look at what actually happened inside our application. That's cool, but we can actually kick this off from the command line. So I'm going to do console.profile, and I'm just going to name it here. And we'll do a little bit of action, and back, and end off that profile. And so just like before, we created a new profile, we have that data. But the more interesting thing is that all this information is available to us in an object as well. And so we have console.profiles, which is an array of all of the profiling information. And this object represents everything that's up in this larger view. But we have it in an object, which is nice. So you can execute these methods inside your application code, get back this data, and then serialize it and shoot it up to your server so that you can kind of see how are users executing certain bytes of code. Another one that I want to show is Mark Timeline. So the timeline view is similar to what we just saw from Dynatrace, where we can record or refresh the page right here. And the cool thing is that we can make little marks. So I'm just going to console.markTimeline. Hi. Hello. So what this does is it just applies a nice little mark here up on the timeline view. And in addition, down here, we have small little events. So the cool thing is that while this timeline view gives you a great idea of what's being repainted, what's being reflowed, kind of the in-browser performance aspects of this page loading, we can inject these little marks with our JavaScript so we can kind of group and get a better picture of how this relates back to our code. All right. So there's a few things here. And I would recommend a lot of these make sense to kind of have in your application code and be gathering metrics, but also encourage you to think about if these can work for you in more of a continuous integration setup, especially performance memory where you need to execute Chrome with a specific thing. But I think you can gather a lot of metrics like this in a continuous integration and track your work over time. Next, we have just added some extensibility APIs for audits. So you can create new tests, kind of like page speed or Y slow, create new tests, and they can take into account all the information coming in from the network. And this is good if you have clients or you have a team and you want to maintain specific standards and make, for instance, sure that there are no images above 80K. You can make that into a rule in a nice, very user-friendly way to enforce that. The next is the Heap Profiler, which just like a month ago got a huge upgrade. So the Heap Profiler is like your tool for digging into the memory consumption of your app. You can get snapshots of the memory usage of your app and be able to get diffs between those, group objects by constructor, view the retain size, which is to say, if this object was disposed of and all the references, how much memory would I free up? So there's a lot in here. And if you're digging into memory leaks or finding the highest memory consumers in your app, I'd really recommend you dig into it. We have a whole new site, a whole new set of docs and demos where you can kind of play around with this, so I'm really excited about that. And the last thing I want to point out is that we just launched this last month remote debugging, and this is really exciting. So I'm running Chromium right here, right? And what I actually did when I ran Chromium is, let me find it. Here we are. I ran Chromium from the command line, and I passed it a flag, and I specified my remote debugging port. Now, what this means is that I'm going to go over to a nightly build a WebKit, and I'm going to open up localhost 922. Now, what happened is that my DevTools in Chromium is actually running a little mini web server. And I just connected to it over in Nightly WebKit. And so these two items refer to my two open tabs. So I'm going to go over here. I'm going to open up these. And so even though I'm in a completely different browser, this functions just like your normal DevTools. And you have full control, too. So I can do memory. I can watch my timeline. I can execute profiling, all this. So I'm really excited about this. This is we have all the network timing information available to you, of course, the full timeline, all of our profiling, both CPU and memory. And the really exciting thing is that all this code has gone in at the WebKit level, which means that all WebKit projects and mobile browsers in particular that use WebKit have this functionality available to them now. It's already shipping in the BlackBerry Playbook, and personally, I'm really looking forward to seeing more mobile devices soon having this functionality. So I guess that's it from me. We have a full site with a lot more documentation on all this stuff and more. And we also have a Google group where we'd love to get your questions and answer things for you. So thanks very much.